So the topic is combinations. The meaning of combination is selection. It's pure selection. So after selecting certain objects from the total number of objects, we need not arrange it. Okay. So if it is selection as well as arrangement, arrangement is permutation. Arrangement without repetition is permutation, but then combination is pure selection. Okay. So the formula for combination is NCR, n factorial upon n minus r factorial into r factorial. Okay. N factorial upon n minus r factorial into r factorial. So out of n objects, if we are supposed to select r objects, total out of n objects, if we are supposed to select r objects, okay, you can use this combination formula. Example, 7C3, 7 factorial, 7 minus 3 factorial into 3 factorial. So that will be 7 factorial upon 4 factorial into 3 factorial. Now you know how to calculate this further. Okay. Yeah. So let us start with exercise 12V of combinations. Exercise 12V. It's very simple. Just be attentive and focused. Okay. Exercise 12V. Question number 1. Fine. So question number 1. How many ways can a committee of 8 be chosen from 10 individuals? So it is on chapter 12, page number 27. Chapter 12, page number 27. Question number 1. So the total number of individuals are 10. N is equal to 10. Out of 10, we have to form a committee only of 8 individuals. So R is equal to 8. So the answer for this will be NCR, which is 10C8. That is equal to 10 factorial upon 10 minus 8 factorial into 8 factorial. That is equal to 10 factorial upon 2 factorial into 8 factorial. Okay. Now 10 factorial can be written as 10 into 9 into 8 factorial and stop at 8. So that 8 factorial, which is there in the denominator, gets cancelled. And this 2 factorial can be written as 2 into 1. Okay, so it will be 90 upon 2, with that is equal to 45. That is equal to 45. Okay, and 10C8 directly you can plug in this values in your calculator as well to get the desired answer. Okay. So please copy this. If you have understood this problem, just put it on the chat box so that I will come to know that if any further help is required. Question number 1, this was. Have you got the solution? Is it clear for you, everyone? Just give me a feedback. Hello. You can put it over the chat box. Please help me with that. Okay. Second problem. Second problem, question number 2. All the questions that will be covered up today are very simple. Don't be overconfident. Just you know, be with me during the session. Don't proceed with the next problems. How many, in how many ways can a committee of 5 persons can be formed out of 8 persons or members when a particular member is taken every time? So now there are 8 individuals. N is equal to 8 individuals. Out of 8, we are supposed to select any 5. Okay. But then they have put a condition. Out of 8, 1 person is selected every time. Okay. So now there is Mr. X, who is a part of this 8 individuals. Now Mr. X will be always a part of this 5 individuals. Okay. So Mr. X is already selected. So now the total number of persons will be 7 because Mr. X is already selected. And total number of persons to be selected is 4 because the total number of selections were 5, but then 1 person is already selected. So eventually the total number of persons is 7 and the number of persons to be selected is 4. So the answer is NCR, which is equal to 7C4. Now you can calculate this later, but then concept wise, have you understood the problem? N is equal to 7, R is equal to 4. Okay, I'll be taking you to the next problem right now. Okay, so question number 3. Question number 3. In how many ways can a committee of 4 be selected out of 12 persons so that a particular person may be always taken? Second part, never be taken. So first part of the problem. N is equal to 12 persons and the selections to be made are 4. We require only 4 individuals. In such a way that a person is always taken. Same problem. Mr. X is a part of this 12 individuals. 12 individuals. Okay. So now Mr. X is already selected. So the number of individuals now are only 11. Can someone tell me the value of R? Mr. X is already selected. Can someone tell me the value of R? Hello, hello. Others? See, Mr. X is already selected. So now we require only 3 persons more in the committee. Okay. So this will be NCR 11C3. 11C3, you have a calculator, you know the method as well, which I have taught you right at the beginning of the session. 11C3. Okay. This is first part of the problem. Are you clear with this first part of the problem? I hope I'm not going too fast. Okay. Second part of the problem. I'll solve the second part of the problem. Fine. Now there are 12 individuals. A committee of 4 is to be made. Now a person is never to be taken, one particular person. Now this Mr. X is a part of this 12. Mr. X is a part of this 12 individuals. But then he can never be a part of this 4 individuals. Okay. He can never be a part of this 4 individuals. Right? So the total number of persons are now 11 because Mr. X is a particular person. Okay. But then this time, what is R? Mr. X cannot be a part of 4. So what is R? How many objects are supposed to be selected? Now this time R will be equal to 4. Correct. Many people are giving the right answer. Right? R will be equal to 4. See, one person is already gone. I'm asking him to leave the room. There are only 11 persons, out of which I'm going to give an entry to only 4 persons. Okay. So 11 C4. So the selections will be made only out of 11 individuals. Mr. X will be sent home. Let us go to question number 5. Let us go to question number 5. Should I? Okay. So question number 5. Sorry, question number 4. I'm sorry. Question number 4. In how many ways can a team of 11 players be selected? Only selection, huh? There is no arrangement over here. From 14 players. When two of them can play as goalkeepers only. Okay. Now see, we have to create a table over here. So there are 14 players. So total, there are 14 players. Okay. Now this total is divided into two parts. Goalkeepers and non-goalkeepers. So how many goalkeepers are there in this 14? There are only two goalkeepers. And how many non-goalkeepers will be there? If there are two goalkeepers, if two players can play as goalkeepers only, how many non-goalkeepers will be there? 12. Correct. Because there are 14 individuals. Two can play as goalkeepers. So there will be 12 individuals who are non-goalkeepers. Okay. So this is the total. Okay. Now out of this total, we are supposed to make selections. Right? I'll just write selection over here. So we are supposed to select 11 individuals on a particular match day. How many goalkeepers will we select when the match is ongoing? It can be a football or a hockey match. We cannot make both the goalkeepers play at a single time. So only one goalkeeper will be given a chance. One will be a standby. What about non-goalkeepers? How many will play? Team is of 11. One is a goalkeeper. So how many non-goalkeepers will play? How many actual players will play? It will be 11 minus 1, which is equal to 10. So this is how 11 players will play. Okay. Guys, are you able to understand this or not? Okay. Now, combinations. Total number of ways. Out of 2, we have to select one. So 2C1. And, I'm saying and. Out of 2 non-goalkeepers, out of 12 non-goalkeepers, we have to select 12, 10. 12C10. 2C1 into 12C10. You can solve this later on. But then have you understood the logic? We are selecting goalkeepers and non-goalkeepers. Okay. And implies multiplication as per theory of counting. As per theory of counting. Okay. So just give me a feedback about whether you're understanding this or not. Tell me, guys. Fine. So let me take you to question number 5. After this, I'll take you to question number 5. Okay. A person has got 12 friends, of whom 8 are relatives. So total number of friends there are 12. So friends are classified as relatives and non-relatives. Okay, and non-relatives. So out of 12, how many relatives are there? There are 8 relatives. So how many non-relatives will be there? There will be 4 non-relatives. So this is a total composition. Now from the total members over here, there will be selections made. The person has to invite only 7 guests. So there will be only 7 selections made. There will be only 7 selections made. Okay. Such that 5 of them may be relatives. So 5 will be relatives. How many non-relatives will be there? If he has to invite only 7 persons, 5 should be relatives. How many non-relatives should be there? Obviously 2. There will be 2 non-relatives. Okay. So number of ways. Okay. Out of 8, we are supposed to select any 5 relatives, and is multiplication. Out of 4 non-relatives, we have to select any 2. So these are the total number of ways. These are the total number of ways. Fine. Yes. Any feedback? Have you understood this, or some confusion is there? Okay. Next problem, question number 6. Now this question number 6 can be an MCQ category problem. How many diagonals are there in a polygon? So number of diagonals in a n-sided polygon, n number of sides, equal to nc2 minus n. nc2 minus n. So the first part, the number of sides are 8. So the number of diagonals will be 8c2 minus 8. 8c2 minus 8. Okay. So you can calculate 8c2 separately, whatever is the answer, subtract 8 from it. So can you put on the chat box, if the n is equal to 10, number of sides are 10, how many diagonals will be there for such kind of a polygon? Can you put it on chat? I want a final answer. calculation as per the formula which I have given you. Please tell me the answer. 35, correct. 35 is the answer. Okay. So let us go to question number 7 now. Question number 7. Okay. In how many ways can a committee consisting of a chairman, secretary, treasurer, and 4 ordinary members be chosen from 8 persons? So the number of persons are 8. Okay. Now we'll first select a chairman. So chairman is only one post, can be selected in 8C1 ways. So out of 8, any one can be the chairman. Have you understood this statement, guys? Have you understood the statement? And now one person has reduced. There are only 7 persons now. Okay. Secretary can be selected in, we have to select only one secretary now. 7C1 ways. Have you understood this? Because one person is gone, so chairman is selected. Now there are only 7 persons. So out of those 7, we have to select one secretary. And treasurer. Okay, now there are only 6 persons left after the selection of chairman and secretary. So how many treasurers will be there? In how many ways can we select a treasurer? To be precise, can you tell me? 6C1 ways, correct. And now the number of persons left are 5. 4 ordinary members. 4 members can be selected in anyone? Four members can be selected in 5C4 ways. 5C4 ways. Okay. So the total number of ways, 8C1 into 7C1 and is multiplication into 6C1. Into 5C4. Okay, guys, have you understood this or is there any confusion over here? Please calculate the final answer and tell me what is the final answer. Calculate this and tell me. Put the answer over the chat box. Correct. 1680. 1680. Right. Okay. Yeah. Next problem. We have to solve question number 8 right now. Fine. 8 sub question A. 8 sub question A. Just a second. You can read the problem in the meanwhile. Okay. Yeah. Please read the problem. Question number 8 sub question A. In how many ways can a student choose 5 courses out of 9 if 2 courses are compulsory for every student? Okay. So N, there are total 9 courses. Okay. R, the person has to select any 5 courses out of 9. Any 5 courses out of 9. Okay. Now 2 courses are compulsory for each and every student. Now course A and course B is already a part of 5. They are already selected. Okay. So eventually, how many courses are left? 7 courses are left because A and B is compulsory for each and every student. And out of 7, A and B is already selected. Okay, out of 5, sorry, out of 5, A and B is already selected. So how many more courses a person has to select? A student has to select. Out of 5, A and B is already a part of 5. So 3 more courses he has to select, he or she. So answer will be NCR 7C3. NCR which is equal to 7C3. Any confusion, any doubts? Any confusion or any doubts? Guys, are you able to understand? Just give me a feedback. Okay. So 8 sub question B. In how many ways can we select a cricket team from 17 players in which 5 players can bowl? In which 5 players can bowl? Okay. Each cricket team must include 2 bowlers. So first classification. Total there are 17 players. Okay. Bowlers and others. Instead of writing batsmen, I'm just writing others. Okay. So how many bowlers are there? There are 5 bowlers. How many batsmen are there? Out of 17, if there are 5 bowlers, there will be 12 other category players. I'm naming others because there will be one wicket keeper among the batsmen also. Okay. Yeah. So this is total. Now selection. How many total players will be selected on a particular match day? Can you tell me? How many total players will be selected on a particular match day? 11. Okay. I'm very sure everybody must be knowing this, right? Now, if you read the last line, each cricket team must include two bowlers. So there should be two bowlers out of five. Okay. So out of 11 players, we have already selected two players. How many other players we have to select? To form the team, nine more players are required. 9 plus 2 is equal to 11. Okay. Now, number of ways. Phi C2 into 12C9 into 12C9. Okay. From 5, we'll select two bowlers, and from other category, total 12 players will select any nine bowlers. Nine players. Okay. This was question number 8, sub question B. You have any doubts or confusions? Any doubts or any confusions? Yeah. So let me proceed with question number 9. This was question number 8. I'll proceed with question number 9. Okay. How many committees of 5 members can be formed with 8 officials and 4 non-official members in the following cases? Case 1. First, we'll write down the composition. Okay. So official members and non-official members. So there are total 8 official members and 4 non-official members. Okay. And we have to make a committee of 5 members. So selection will be of 5 members. Okay. Now the first part says there will be 3 official and 2 non-official members. They are very clear about it. So number of ways 8C3 into and non-official 4C2. Just give me a feedback whether you're understanding the first part. 8C3 into 4C2. Okay. We'll go to the second part now. Once we have copied this. Okay. So I'll proceed with the second part of the problem. Total officials and non-officials I'm going to write. 8 officials and 4 non-officials. Okay. This is the total. Now selection will be done in cases. Okay. Don't write anything. First C. Now out of 5 members, we have to create a committee of 5 members. It is given right at the beginning of the problem. There should be at least 2 non-official members. Okay, so greater than or equal to two non-official members will be there. At least means greater than or equal to. At least means greater than or equal to. This is at least. At most is lesser than or equal to. Just remember this keywords. You can make a note of it. Okay. At least is greater than or equal to. So just write down greater than or equal to two near non-officials. Okay. So case one, selection is to be made of 5 individuals. Okay. Just remember that. So there will be two non-official members. So how many official members will be there in a team of 5? I'm starting with two non-official members. Okay. So how many official members will be there in a team of 5? 3. Correct. I hope you are understanding this. Case 2. Now this 2 has to increase. This 2 has to increase more than or equal to 2. So the first case was 2 non-official members. Second case will be 3 non-official members. It can be more than 2 as well. So how many official members will be there? Two non-official members. 2 official members will be there because the selection is to be made of 5 individuals. Case 3. Increase this 3 to 4 because it is more than or equal to 2. Okay. So if there are 4 non-official members, how many official members are there? There will be one official member. Correct. Case 5. Case 4, sorry. Now 2, 3, 4. We'll write this as 5. Okay. 5 non-official members. So how many official members will be there? If there are 5 non-official members, how many official members will be there? 0. Selection is to be made of 5. So 5 are already selected. So there will be 0 official members. Now guys tell me, is case 4 really possible? Some people have already figured out. On purpose I had written this. Case 4, is it possible? Case 4 is not possible because there are only 4 non-official. So how can you make a team of 5 non-official members? Total are only 4. How can there be a case 4 over here? Have you understood this, guys? Have you understood? Okay. So how to present this now as the final answer? Okay. Total ways. Case 1 or case 2 or case 3. Guys, what is OR? Addition or multiplication? This is the basic. OR is addition. Okay. Now case 1 answer. Out of 8 we are selecting 3. Out of 4 we are selecting 2. Okay. Case 2 answer. Out of 8 we are selecting 2. Out of 4 we are selecting 3. And case 3 answer. Case 3 answer, can you tell me, guys? If you can tell me, case 3 answer. Case 3 answer. Correct. Out of 8, we are selecting 1. And out of 4, we are selecting 4. Now you can calculate the individual values using a calculator. 8C4, 8C3, all these things are very easily calculated using a calci. Okay. Don't waste your time in applying the formula. You can do that, but then there will be a time waste. Question number 9, sub question 3. Okay. I hope everybody understood this. Second part, everybody understood? Question number 9, sub question 3. So the official members are 8. Non-official members are 4. Okay. Now we have to make a selection of 5 members. A particular official member is never included. Now there are 8 officials standing in front of you. I'm asking the first official member to leave because he's not going to get selected. So how many official members are left? How many official members are left? 7. Correct. Now selection is of 5 individuals. Okay. Now there is no criteria of how many officials and how many non-officials will be there. There is no criteria in the third problem. So n is equal to 11. There are total 11 of members, out of which we have to select any 5. There is no criteria like how many total number of official and how many total number of non-official members are there. See, problem number 1, problem number 2 had criteria. Okay, so this will be 11C5. 11C5 is. Okay, guys, have you understood this or you haven't? Feedback. Come on, please. Just give me a feedback. Okay, next. Question number 9, sub question 4. Okay. Official and non-official members. Total. There are 8 and 4. Selection. 5 members are to be selected for the committee. Okay. Now what is a condition over here? One particular non-official member is always included. Okay. Now out of 4 persons over here, one person is always a part of over here selection. One person is always a part of that committee. So how many non-official members are left? 3. Because one person is already entering into selection. Now out of 5 members to be selected, one person is already selected. So how many more selections we have to make? How many more selections we have to make? 4, because one person is already selected, right? Now n is equal to 8 plus 3, which is equal to 11. Now there is no bifurcation of the committee that they have given, like question number 1 and 2. So there are total 11 players, 11 members, out of which any 4 are supposed to be selected, because one person is already selected. So the answer is NCR, which is equal to 11C4. NCR, which is equal to 11C4. Guys, a feedback about the fourth sub question. If you can help me with the feedback. Have you understood this? Yes or no? Okay, those who are choosing not to reply, I hope you are attending and understanding. Yeah. Question number 10. Question number 10. Please read the problem very clearly. In a college team, there are 15 players, out of which 3 are teachers. So total is 15 teachers. Okay. And non-teachers. So how many teachers are there? There are 3 teachers. So out of 15, there are 3 teachers. So there will be 12 non-teachers. We'll solve the first sub question. We have to make a team of 11 players so as to include only one teacher. So selection is of 11 players. There should be one teacher. So out of 11, one teacher is selected. So how many non-teachers are left? 10, because 10 plus 1, that is 11. And that's how your team will be formed. Okay. This was pretty simple. Number of ways, 3C1 into 12C10. 3C1 into 12C10. Okay. Guys, have you understood the first sub question? Yeah. I'm taking you to the next sub question. There should be at least one teacher. At least means greater than or equal to. Okay. Question number 10. Sub question 2. Teachers, non-teachers. Teachers are 3. Non-teachers are 12. This is total. Selection. Selection of 11 individuals. They have put one condition on the teachers. The teacher should be at least 1. The teacher should be at least 1 in the team. At least means greater than or equal to 1. So this will be case wise. Case 1. There will be one teacher. So in the team, how many non-teachers will be there? Team is of 11. How many non-teachers will be there? 10. Correct. Case 2. Greater than or equal to 1. So it can be more than one teachers also. So 2 teachers. How many non-teachers will be there? How many non-teachers will be there? 9. 9 plus 2 is equal to 11. Case 3. There can be 3 teachers. Go on increasing that one. How many non-teachers will be there? 8. Now guys tell me, will there be case 4? Correct. There won't be case 4. There won't be case 4. Okay. So number of ways, case 1 or case 2 or case 3 or is addition. So guys, what is the answer for case 1? What is the answer for case 1? 3C1, correct. Into teachers and non-teachers. 12C10. And is multiplication, you all know that. Case 2, 3C2 into 12C9. And case 3 will be 3C3 into 12C8. Are you able to understand? Okay, fine. Now directly we'll go to question number 22. Question number 22. Just go through the problem and will you tell me if you can solve it? If yes, then definitely we'll take it for self-study. Otherwise, I will solve it for you right now. Is it manageable at your end? Question number 22. Okay. So question number 22, I leave it up to yourself. Okay. Question number 26. Mark question number 26. There are 6 gentlemen, 4 ladies, 5 persons are to be selected in such a way that at least one lady should be there. Guys, how many cases will be there for question number 26? At least one lady should be there. How many cases will be there? There will be 4 cases. The number of ladies will start from one lady, 2 lady, 3 lady, or all 4 ladies. 5 persons is to be selected. Someone said 3, but then have you got the point? Yes or no? Any confusion in question number 26? Mark it for self-study. Then let us go to question number 27. Question number 27. Okay, out of 3 books on economics, 4 on political science, 5 on geography. Okay, so I'll just write it. Eco, political science, and geography. 3, 4, and 5. This is the total. Okay. How many collections can be made if collection consists of first part of the problem? Exactly 1 book. So selection will be exactly 1 book from each one. So the total number of ways is equal to 3C1 into 4C1 into 5C1. Guys, have you understood this? Have you understood this? Or is there any confusion? Okay. Now, second part. At least 1 book on each subject. At least 1 book on each subject. So all 3 will be having at least 1 condition. Okay. Now there will be many cases over here. Okay. Case 1. So English at least 1. At least 1 should be there. 1 and 1. Case 2. Now increase the case for English. So there can be 2, 1, 1. 2, 1, 1. Okay. Case 3. Okay. 3, 1, 1. Okay. Case 4. There can be at least 1 on English. So it can be more than 1 on English. That is 2. There can be 2 on political science. Okay. Or other, what we will do is we'll take 1 on geography now. 1 on geography. And then we'll reverse this. Case 5. There will be 2 on English, 1 on political science, and 2 on geography. Right? Case 6. 2, 2, 2. Okay. Are you able to understand? Are there more cases? Yes, there can be so many cases like this. Right? But then if we solve it this way, it will be very lengthy. There are so many cases, so many possible combinations. So what we are going to do is, we are not going to follow this method for this problem. Okay. We'll proceed as per theory of counting. Okay. So books on English can be selected in 3C1 or 3C2 or 3C3 ways. Okay, are you able to understand? See, there can be one book on English, or two books on English, or three books on English, all three books on English. Okay, at least one. So more than or equal to one, greater than or equal to one. Guys, have you understood this statement? And what is or? Or is addition. So this is only for English. And I'm saying and because we are selecting books on political science as well. So for political science, what are the total number of ways? Can you tell me? At least one book should be there on political science, more than or equal to one. So what are the different cases? Out of four, any one book will be there, or is addition. Out of four, any two, or out of four, any three, or all four. This is for political science. And okay, for geography, it will be 5C1 plus 5C2, 5C3, 5C4, 5C5. Guys, have you understood this or are you finding it difficult? Okay, now we'll get three different answers. For English, you'll get one answer. For political science, you'll get one answer. And for geography, you'll get one answer. What should we do with these three answers? Should we add or should we multiply? Please tell me, should we add or should we multiply? Yes, we are going to multiply because we are placing and in between. We are placing and in between. Just give me honest feedback on question number 27, sub question 2. Have you understood this or not? Okay, so let me give you one note. After this, we'll just write one note. Okay, I'll just write it. You'll have to copy. Yeah. So first note, out of n points, okay, no three or more points being collinear. See, 2 points are always collinear. Okay, but then here the condition is no three or more points being collinear. Any 2 points are always collinear, but then 3 points may or may not be collinear. So no three or more points collinear. Number of triangles formed will be NC3 ways, and number of straight lines formed will be NC2 ways. Please copy this. This is the first note. Yeah. Question point number two. Point number two. I hope everybody has copied this. Point number two. I'm making some changes over here. Just wait. Out of n points, if m points are collinear, some specific points are collinear, and m is always greater than or equal to 3. The number of triangles that can be formed are nc2, nc3 minus mc3. nc3 minus mc3 ways. And number of straight lines will be nc2 minus mc2 plus 1. That many number of ways. Please copy this. Guys, have you copied this? Okay, okay, please copy. Okay. So go to exercise 12B. Exercise 12B. Question number 21 and question number 24. Okay. Question number 21 and question number 24. We are supposed to solve. In question number 24, 21, there are 9 points. There are 9 points. And we need to form a triangle. First part is no 3 points are collinear. So the number of triangles will be nc3, which is 9c3. But then in the second part, out of 9 points, 5 points are collinear. 5 points are collinear. So the number of triangles will be nc3 minus mc3, which is equal to 9c3 minus 5c3. 9c3 minus 5c3. Yes, guys, have you understood this or not? Just give me a feedback. You can try 24th problem on your own. I'll just wait for you and then I'll discuss. Okay. So question number 24. There are 12 points. Okay. Out of which 5 are collinear. So M is equal to 5. First part, the number of triangles that can be formed is equal to NC3 minus MC3, 12C3 minus 5C3. And second part, the number of straight lines that can be formed. So NC2 minus MC2 plus 1. So 12C2 minus 5C2 plus 1. Okay, that plus 1 is separate. Towards the end, you have to add plus 1 to the 12C2 minus 5C2 part. Yes, guys, have you understood this problem or is there any confusion? Please tell me. Waiting for your feedback, guys, please. Okay, so next note, just write a note. If NCX is equal to NCY, there are two parts. X equal to Y or N is equal to X plus Y or N is equal to X plus Y. Okay. When to apply this note? When the total number of objects are same and there is equal to sign in between. X and Y will be different. The total number of objects are same, X and Y are different, and there is equal to sign in between. Okay, just copy this note. This will be very important for us in some of the problems. Okay. So let us solve some problems based on this. Exercise 12B, question number 12. Exercise 12E, question number 12. NC10 is equal to NC14. Okay. Now, can I compare this with NCX is equal to NCY? Can I do that? Can we compare this situation with NCX is equal to NCY? Yes or no? Because total number of objects are same, right? So this gives me two things. X equal to Y or N is equal to X plus Y. Or N is equal to X plus Y. Okay, guys, who is X? Please tell me. Who is x? What is the value of x? What is the value of x? X is 10, correct. And what is the value of y? Okay, 14. So x is 10, y is equal to 14. So this case is absurd. 10 and 14 cannot be same. Case absurd, similar to marks that some of you have scored. And n is equal to x plus y. X is 10, y is 14. So n is equal to 24. So we got the value of n, 24. Guys, have you understood this much? Yes or no? Okay. But then the problem is not yet over. We need to find out NC20. So 24C20. See, the value of n is 24. Value of n we have calculated as 24. So NC20 is 24C20. This you can calculate using calculator. And 25CN is equal to 25C24. This also you can calculate using a calculator. Put the value of n that you have got in the previous part. Let us go to exercise 12D. Exercise 12D. Exercise 12D. 1, 2, and 3 are for self-study. 1, 2, and 3 are for self-study. Okay. So let us start with question number 4. Question number 5 of exercise 12D. Question number 5. NC4 is equal to NC6. Is this NCX equal to NCY? Is this NCX equal to NCY? Category? Yes. So there are two cases over here. X equal to Y or N is equal to X plus Y. So 4 is equal to 6, case absurd. And N is equal to 4 plus 6, which is equal to 10. This is a valid case. Sometimes you might get two valid cases as well. There will be two answers. Okay. Not every time. Sometimes both the cases will be valid. Not every time. This was question number 5. Question number 8. I'll be solving question number 8 right now. C n comma 10 equal to C n comma 12. NC10 is equal to NC12. Cn comma 10 is nothing but NC10. You have learned this kind of notation in permutation as well. Okay. Is this of the category NCX is equal to NCY? Is this of the category NCX is equal to NCY? Yes or no? And N is same, equal to sign in between. So two cases. Case 1, case 2. X equal to Y or N equal to X plus Y. So 10 equal to 12, X is 10, Y is 12, N is equal to 10 plus 12, which is equal to 22. Okay. So the problem is not yet over. You have to be alert. I can see some students earlier while writing the midterm at your school. Many of you lost marks because you were not alert while writing the papers. So you have to complete this problem. N is equal to 22. First case is discarded. Okay. So they are asking you to calculate Cn comma 25. N comma 5. C n comma 5 is nothing but NC5. N is equal to 22. So don't forget to calculate this. Okay. I hope you have done this. Copied this calculation part. The last answer you can do it later on. It's very easy. Fourth, problem number 4 from the same exercise. 4P2 is equal to N into 4C2. Okay. So there are multiple ways you can use calculus and solve this as well. But then I'll use the formula. What is NPR formula? N factorial upon N minus R factorial equal to N into NCR formula. 4 factorial N minus R factorial into R factorial. So 4 factorial will get cancelled on both the sides. 4 minus 2 factorial, 4 minus 2 factorial cancelled on both the sides. So we'll be left with 1 is equal to N upon 2 factorial. So what is the value of N? The value of N is 2 factorial, which is 2. Okay. Otherwise, you can calculate 4P2, 4C2 using calculator and put it in the given equation. Okay. Let us solve question number 9. After this problem, I'm solving question number 9. Which is the last problem. Okay. C 2n comma R equal to C 2n comma R plus 2. So 2n CR is equal to 2n C R plus 2. The number of objects are same, 2n 2n. So can I go ahead with NCX is equal to NCY formula or property? Because the top objects are same. n, 2n, 2n, and there is equal to in between. Can I go ahead with this? X equal to y. So guys, what is x? X is r and y is r plus 2. So 0 is equal to 2. Case absurd. N is equal to x plus y. Guys, in our comparison, what is n? Can someone tell me what is n? When we compare it with the property which we have written, what is n? Correct. N is 2n. 2n equal to r plus 2. Okay. So 2n is equal to 2r plus 2. 2n is equal to take 2 common. R plus 1. 2 is getting cancelled. So n is equal to r plus 1. They are asking r in terms of n, not n in terms of r. So r is equal to n minus 1. R equal to n minus 1. That is the answer. So that is the end of session number 1 on combinations. Okay.